All right, so I'm going to go over how to solve these problems because they're a little bit complicated. So GPP in our first problem that we're reading is told to us to be 0.012 grams per centimeter squared per day. We're then told respiration is lost at about 20%. So how you solve for that, like how are you finding respiration? We know respiration is like part of the GPP, right? So then we have to do 0.2 because a percent is just a decimal with it moved over twice, times the GPP, okay, which in this case equals, highlight I guess what I wanted, so 0.2 times that. Okay, and in this case this equals 0.0024 grams per centimeter squared per day. All right, and how do we solve for NPP? We were given our equation above, which is GPP minus R lost, which is what we found. So that is going to be NPP equals to 0.012 grams per centimeter squared per day minus 0.0024 grams centimeter squared per day. And that gives us a total of 0.0096 grams per centimeter squared per day. All right, so that's how you solve that first part. Then you need to find efficiency. So an issue we have is that we need to take it out of centimeters squared because when we're looking at the calories, that insulation energy, we are only dealing with meters squared. So we need to convert this number into meters. You know what, I'm going to set this up. It's going to be a little annoying, I think, for me to do, but it'll be helpful. All right. So we're multiplying and we're trying to get rid of centimeters squared. So 100 centimeters, actually I think we just keep this underlined the whole time. 100 centimeters is equal to 1 meter. And 100 centimeters is again equal to 1 meter. So the question is, well, why am I doing it twice? Like, why can't I do it once? Because we have to get rid of every single one of our squared elements. So centimeters, so I get rid of it once, then I have to get rid of the square as well, because it's technically centimeter squared. It's just centimeter times centimeter. Okay, and then I've gotten rid of that, and now I need to convert my grams into calories. Okay, so I am told that 1,000 calories is equal to 1 gram. And once you do that, then you get to do work with your insulation energy, which is for every meter squared, you get 6 million, hypothetically, calories. Obviously, you're not getting all of those, and we're actually dividing that mass. And this equals let's see what I did. 0.02, everything gets crossed off. I'll kind of get rid of my underline. 0.02, and you multiply that by 100%, which equals to 2%. Okay, hopefully that helps a little bit. If you're really struggling, these are pretty tricky problems. You're going to want to check in with me.